Okay, so we'll start the class right now. Okay, so actually, I've sent you all these notes for the topical past year, right? I just noticed that the phone number over here, I wrote it wrongly. Yeah, this should be 016. So just in case if you want to contact me, you need to change this number, or else you contact someone else. Okay, so let us begin. Okay, today, our main focus is chapter 6 past year. Then we'll talk a little bit about chapter 2. Then we'll proceed to chapter 6. So before that, let us try to analysis a bit about the STPM question. So by looking at this topical past year, the past year is from 2013 until 2024. So we can say that it's actually all the past year for the current syllabus. So you can notice that actually if you notice that the question every question 1 is from chapter 1, then every question 2 is from chapter 2. So the question number is according to the chapter numbers. So when you solve the problems, you can actually target the chapters that you want, then you can straight go to find the question. Okay, then after that, for question 7 and 8, mostly question 7 come from chapter 1. Then mostly question 8 come from the chapter 6. So you can go down and see there is a section B. Question 7, we have 1, 2, 3, 4, 5, 6, 7. Okay, so 2013 until 2014, there are 12 years. But there are 7 questions of question 7 come out from chapter 1. Then if you go to check, you will found that chapter 4, there are no question 7 or 8 came out from it. It is for question 4. For chapter 4. Yeah. Okay. There are no section B question came out from chapter 4. Then for question 8, mostly come out from the chapter 6 vector. And if you check, there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 12 questions come out from chapter 6. So by this, we know that chapter 6 is a very important chapter. And comparing chapter 1 and chapter 6 is actually more important because chapter 1, the chapter is very large, right? So we feel that it is very, very large, and we think that it is very important, but actually it's opposite because it's too large. Then we don't know for sure that which question it will come up. So if you focus more on the chapter 1, you need to learn many things. Then it might cut out one small topic on it. But for chapter 6, the scope is quite small compared to chapter 1. So if you focus more on chapter 6, you learn a little bit, you can solve question 6, and also for the last 2 questions, if you don't know how to do the maybe chapter 1 question, it came with question 7, then you can still do the question 8 question. But of course, this is not for sure. Just mostly, it has a very high probability that came out question in question 8. Yeah, still have about 3 years it didn't come out in question 8, right? So it's not for sure. It has a high chance to come out in question 8. Okay, so now we go to see the question 2 first. Okay. Okay, so for chapter 2, actually there are some things that you must know before you can answer the question 2, chapter 2 questions. So I try to list out some for you. So the most important thing actually is the arithmetic and geometric progression. Okay, so for chapter 2, there are some basic techniques that we need to know. Because actually, if you notice the question style, there are some question that uh they we can say that it is the basic question that it will that we see commonly lah. Then we can normally we are able to solve them. Then so sorry. Okay, so if you look at the question, normally it will divide into part A, part B, part C, right? So if there are many parts, there might be some parts that we cannot solve. But of course, there are still some parts that we can solve. Our target should be we target to solve the part that we are able to solve to the most, okay? Try to solve as much as possible. So there are many basic things that we can learn that can solve most of the basic, the easy question. Okay, so for chapter 2, the most important thing you need to learn, okay, of course, is arithmetic and geometric progression, right? Okay, of course, and their formula, okay, formula. And geometric progression formula. Okay. After that, you need to know one most important thing. You need to know how to prove that something is in AP and something is in GP. Okay. Okay. I think like proving AP and GP is very important. So how we prove that something is in arithmetic progression? Okay, there are two different ways you need to know. Of course, there's actually one way only, like is to prove that their common difference is a constant, right? Okay, but when you prove, if you look at the uh the sequence that are given, if they just give you like 3 or 4 numbers only without the dot dot dot, like let's say it puts like this 1 3 5, show that this sequence in is arithmetic progression. If it says like this, then you can just do like 5 minus 3 equals to 3 minus 1 equals to 2, okay, equals to constant. Then you can say that it is a arithmetic progression. But if there are dot 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 at the end, then you cannot do like this. Because if there are no dot dot dot, it means that there are only three terms inside the sequence. So if there are only 3 terms, then by proving, like relating these 3 terms, you are actually proving the whole sequence already. But if there are dot dot dot, it means that the sequence go infinitely. There are still many terms behind, right? By just proving the first 3 terms, you cannot show that the whole sequence is also the arithmetic progression. If something like this happen, you need to write the formula of UN, or we say UR, right? Okay, you need to find the formula of UR. Okay, let's say for this case, UR will be, we know that it is arithmetic progression formula, right? So we go to find the formula of arithmetic progression and sub for it. So for UR, it should be, okay, normally they should give you the formula, okay? Normally they should give you the formula, okay? Or else you need to try to find the formula for it and prove that it has a common difference. Okay, so let's say we know that the formula for UR, okay? I'm not trying to prove it here for you. So let's say we know the formula for UR is given by the question. So if you want to prove that it is an arithmetic progression, you need to do something like this: UR minus UR minus 1. So UR minus UR minus 1, if you found that it is some number which is a constant, then it is an arithmetic progression. Okay? Okay. Then for GP, it is actually the same. So if you try to prove something, let's say 1, 2, 4. Okay, so if you only have 3 terms, then you can straight just divide the third term by the second term and divide the second term by the first term. Then you say that it is a constant. Okay, it is a geometric progression. But if it has the 3 dots behind, if it is something like this, then you need to find the the formula for UR, okay, for the R term. Or sometimes they write as UN, or sometimes TNTR. Okay, there are many types of the formula. So if you can find this, the R term, we say that is the general formula, then you do in the general way. Then if you do this in the general way, it means that every terms fulfill this condition. Okay. If you just prove the first three terms, then it's only the first three terms fulfill this condition. So you need to notice this. Okay. Try not to lose marks on this. Okay. So after that, after you learn the formula for geometric progression, arithmetic progression, learn how to prove arithmetic progression, then the next things that you need to know should be, okay, let me check. Okay, for geometric progression, actually, we know that there is a sum to infinity formula, right? You need to know the formula for sum for infinity. Okay, so the sum for infinity for geometric progression, okay, sum to infinity is actually a over 1 minus r. Okay, but for you to use this formula, there is actually one limitation you need to know. The limit is that the modulus of r must less than 1. Okay, this can also be written as like -1 less than r less than 1. It's actually the same lah. Okay. Okay. Then okay, sometimes other than this, you might found that there are something called recursive formula, right? Recursive formula and explicit formula. Okay, so for recursive formula, sometimes it will like ask you to write the formula in recursive formula. Sometimes it will ask you to write the formula in terms of like explicit formula. So what is the difference? Okay. So for recursive formula, recursive means that it always calls back the previous terms. So the formula might be something like this. For example, UR equals to UR minus 1 plus D. Okay. Okay. It can also be like UR equals to, okay, let's say K times UR minus 1. Okay. Okay. So for explicit formula is different. Explicit formula, the formula depends on the number of the terms. So for example, your formula for the arithmetic progression a plus, okay, r minus 1 d, right? Okay. Okay. So for explicit formula, it means that is in terms of the number of terms, the r. For recursive formula, it always calls back its previous term. So for one most simplest recursive formula that it will ask you to derive is that you need to see that if the sequence is arithmetic progression, then you always use the property of arithmetic progression, which is UR minus 1 is a common difference. Then you just rearrange this UR minus 1 to the back, you will get the recursive formula. Then for the geometric progression, if you notice that it is a geometric progression, actually it's very easy to write in the recursive formula. You just use the property that UR over UR minus 1 equals to a constant. Then you multiply this to the back, you will get this recursive formula. Okay, so it's actually quite straightforward. Okay, so other than that, actually there is still one most important thing, which is method of difference. So as you can see, there are many questions that they ask about method of difference and which we don't know how to solve. If you know how to solve method of difference, actually you can solve like mostly like 80% of the question already. Okay, so you must know how to do the method of difference. Okay. So when you do method of difference, maybe there are one thing that you need to know, which is how to express the fraction in partial fraction. So it can, we say that is something that you need to know before you can do the partial method of difference. Partial fraction. Okay, you need to know how to show something in partial fraction, because many terms, because when we want to use method of difference, we need to ensure that there is a difference of every terms can be expressed as difference of some two different things, right? So let's say we need to express some term UR into the difference of two different things. Let's say FR plus 1 minus FR. Okay, so we need to make some term into some two different things, some different of two terms. Okay, so we can use partial fraction. If UR is a fraction, there is a high chance that we can use partial fraction to make it into the difference of two terms. So after that only we can use method of difference. Okay. So if you know method of difference, you can solve most of the question. Normally the question will ask you to use method of difference to find UR first. To find the sum. Method of difference is you to find the sum. So you can find sum to the nth term, right? Use method of difference. Then after you find sum of the nth term, it might ask you to find the sum to infinity. So how to find the sum to infinity? You use the formula sum to infinity is equals to limit n to infinity Sn. So you limit your sum to n term to infinity, you will get the sum to infinity lah. Okay, so let me see. I think normally they like to ask you something like this. Ask you to find Sn, then sum to infinity. Okay, so how do we know that it is method of difference? Actually, you can think like this. The series, by series we means addition of many terms or subtraction of many terms. Okay, there are difference between sequence, series. Okay, sequence is just they arrange in a certain order by using comma. Okay, by using comma. Series we means they are adding up together. Okay, they are adding up. If they didn't add up, we didn't call it series. We call it a sequence. Okay, so by series, we means that we are trying to add them up or minus all of them. So the series that we can find, actually there are only three types of method we know. The first type is arithmetic series. The second type is geometric series. Quite common, right? Arithmetic series, geometric series. Other than that, it must be method of difference. Just how you apply the method of difference in your question, okay, to solve your answer. So when you think there are no other way, you must recall the three methods that I've stated. Okay, arithmetic, geometric, and method of difference. Okay, so after that, there's still one part that is quite important, which is express in series. Okay, not series. The binomial expansion. Okay, binomial expansion. Okay, so for binomial expansion, there is actually two main formula. Okay, actually you only know one type of formula. Okay, one is binomial theorem, another is binomial series. Actually, they are the same. Just for binomial theorem, okay, if you have a plus x power n, where your n is positive integer, then you have one formula, right? N is positive integer. Okay, so if n is positive integer, then this a and x can be anything, okay? Just two them add up together, then you can use your binomial theorem to expand it. So if you use binomial theorem to expand it, you should get some formula of the binomial theorem, right? This one is okay. should be a power n equals to plus nc1 a power n minus 1 x power 1, okay, at nc2 a power n minus 2 x squared, okay, plus dot dot dot, until the last term ncn x power n, right? Okay, so this is the binomial theorem for positive integer. So if for positive integer over here, inside this, it can be anything. Okay, it can be any two things. So it only need to be two terms add up together, or actually minus also can. If you have minus, then you just do something like this. A minus x power n actually is equals to a plus minus x. Okay, so you use the minus x to substitute the x over here. Okay, you will still get the same thing. Okay, so there is another thing about this binomial theorem, which is we normally call it binomial series. Okay, so if your power is not positive integer, like is other than positive integer, let's say a fraction or a negative integer. Okay, if it is a fraction or a negative integer, then you must ensure that inside the bracket it must be 1 plus something. Okay, it must be 1 plus something. Then only you can use this formula. So if inside is 1 plus something, this n can be any real number. Okay, can be any we call can be actually it can be any real number. Okay, so it can be fraction, can be integer, it can be positive integer also. Okay, positive integer also can apply inside. It is a more a bigger formula. Okay, but it's only apply for 1 plus something type of questions. Okay, so if for this we have the formula 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 n minus 2 over 3 factorial x cubed. Okay, so for this page is all the things that you need to know, okay, before you go to the SM. Okay, so let us see the question over here. If you try to analyze, you can see that, okay, sequence A1, A2, A3 defined by AN equals 3n squared. Difference between successive terms of the sequence, okay, forms a new sequence B1, B2, B3. Okay, express Bn in terms of n. Can we do something like this? Actually, we can, right? Bn is what? Bn is the, okay, difference between successive terms. It means like B1 is equals to A2 minus A1, okay? B2 is A3 minus A2. You just try to sub the n inside and you try to minus, you will get the formula for B1, B2, B3, B4. So how to get the formula for Bn? So B1 is A2 minus A1, right? B2 is A3 minus A2. So Bn, by looking at the pattern, Bn should be An plus 1 minus An, right? An plus 1 minus An, you will get something like 3n plus 1 square minus 3n, okay? Then you further simplify, you will get the formula of Bn, right? Just expand this, simplify it. Show that B1, B2, B3 is an arithmetic sequence and state is first term and common difference. So you see over here, it asks you to show that it is arithmetic progression. I said that this is very important, right? So you try to prove out the formula for Bn. When you have the formula for Bn, it is actually the general formula, right? So we just directly use the general formula to prove that Bn minus 1 is a constant. Okay, if you get a constant, then you know that it is the what? The arithmetic progression. Okay, state is first term and common difference. The common difference just Bn minus 1. The value will be common difference. The first term is B1. So you have formula of Bn, you just sub 1 into the n. You will get the first term. So sometimes we might not be able to do the last part. Okay, it's okay to not be able to do if like you are not very like the top student. Okay, it's actually okay to not complete the whole question, but at least you try to finish part of it. Okay, but for this question C, I think it's quite easy and quite straightforward. Find the sum of first and third of the sequence B1, B2, B3. Okay, so actually it's a little difficult, okay, because it want to show in terms of AN and BN. But you know that it is arithmetic progression. You try to put it in the arithmetic progression first. Okay, you use the arithmetic progression formula first. Okay, then try to somewhat make up the AN and BN into the formula. Okay, but it is okay if you are not able to do the last part, because you see the question mostly the marks are for the front part, then the last part normally like 1 or 2 marks. Okay, so we don't like struggle ourselves to solve the last part of the question. Many of us we are not able to manage to finish the whole question. So if you like stuck to the question 1, question part C, then we are not able to solve it, but you still stuck to it and not trying to proceed to the next question, then you will waste a lot of time. And because it is actually quite difficult and it's only cost 2 marks only, you only got 2 marks only, then you waste a lot of time and still not be able to getting these 2 marks. So our tips is like this, okay? We try to solve the front part, which we are able to solve quickly first. Then if there are some part that stuck, we cannot do it, like the last part. Normally the last part is the most difficult things, okay? If we cannot solve it, then we just like mark a star over there, then try to skip to the next question first. When you do your question, you don't do it like continuously. You do 1 page for 1 question, so that easy for you to manage your question paper, so that later when you want to add something behind, you still be able to add something over there. Okay, so you do 1 page for 1 question. So when you go to the next question, okay, so if let's say C you cannot do, you skip to the next question first. Okay, do the next question, part A, B, C. Okay, part A, part B first, then the part C, if you cannot do, skip to the next question, do all the part that you can do first. Okay, then only come back to do the difficult part. Okay, so let's say sometimes there are very difficult question, like question 2 came out, that you cannot solve the hands. Okay, I know that most of you cannot solve this part, right? It's actually very difficult. Okay, but our target is not to solve, like what I said, our target are not to solve the whole question. It's very difficult to solve the whole question. Okay, it is for the A++ student. Okay, not for the A student. A student might not be able to solve the whole question, but they know how to solve the question that they know how to do. They will know how to skip the difficult part. Okay, so if you don't know how to skip the difficult part, you are stuck to the difficult part and waste your time. Okay, so for this question 2, let's say I say that there are some simple things that we can do, okay, to help us solve most of the question. So this is something that I said just now. Use the binomial expansion of these two to evaluate these two. So binomial expansion, you just need to memorize the formula, then you can expand it, right? So this one you can expand, this one you can expand. Then you obviously you can like add up these two and get the formula for, okay, these two combined. Okay, so actually you should be able to do until here. Can show that this part. Okay, so try to think of it first. If they are actually no idea how to do this, then just skip to the next question. Okay, so our target is not how to solve the most difficult question. We want to solve the most common question, the easy one. We want to solve all of it. Okay, this is actually our target. The target to get A, okay? Or probably not to get A, but to maximize your marks. Okay, of course, if you are the A++ student that every time you do your question you get 55 and above, then you like everything is not difficult for you. You can just proceed to do question 1 until question 6, like water flowing, right? So very easy. Okay, so let's say you see this question 2. Okay, I try to analyze the question for you, okay? Because we want to proceed for question 6. So question 6, I will discuss more in details. This one, I think is quite straightforward. So I discussed how we should target on the question. Okay, so the R term UR of an infinite series, let's say, is given by this. Okay, express UR in the terms of this, where A is a constant. So how do you make it something like this? You see that these two terms add up together, right? You want to make it something like this, try to add these two up, okay? When you try to add these two up, you should get something in the form of this, then you will get this A. I think this can be done, okay? This can be done. Okay, just try to add up these two fractions. So this is actually 2 marks. Okay, then find the sum of the n terms of the series and deduce the sum of infinite series. Okay, here you might be stuck, but remember what I say, for series, there are actually only 3 types of series that you have learned. So the first type of series is arithmetic series. Second is geometric series. The third is a method of difference. So is there any difference of 2 terms that it express for you? Actually, there are no difference of 2 terms. You see, this UR before that is the summation of 2 terms. Okay, so it's the summation of 2 terms. It is not the difference of 2 terms. So we cannot use method of difference. Okay, so we only left with arithmetic series and geometric series. Is there any possibility for arithmetic series? Actually, it's not. Okay, you see that it asks you to find sum of infinity of the infinite series. I give you a trick. If you want to find sum of infinity, there are only 2 types of things that can find sum to infinity. The first is geometric series. Another one is if you use method of difference to find something, then it have a chance that it can find sum of infinity. But if you are arithmetic progression, they are impossible for it to have the sum of infinity series. Okay, so if we like cut off the possibilities, this part B, it must be geometric series. Okay, if you try to think of it, it must be geometric series. How can this be geometric series? Okay, you see, this is UR in the form of A over 3R plus 1. So let's say, okay, I didn't try to solve the question. We don't know the A, but if you try to do this, you will get the A. But if you try to find U1, you will see that U1 equals to, okay, A over 3, 2 times 1 plus 1 equals to A over 3 power 3, okay? Then U2 will equals to A over 3 power 2 times 2 plus 1, which is A over 3 power 5. U3 will be equals to A over 3 power 2 times 3 plus 1, which is equals to A over 3 power 7. Okay, you can notice that there are common ratio between them. Okay, the common ratio is actually 1 over 3 squared. Okay, so if you are able to get this common ratio, how should we actually get this common ratio? Okay, the proper way should be you use UR over UR minus 1 and get the common ratio. Okay, so you express in terms of R. Okay, this is the proper way. Okay, if you try to divide it, you will actually still get 1 over 3 squared. Okay, this is the not so proper way. Okay, not so proper way means that we see from specific cases. Okay, we list out the value, then try to check the difference. But this is actually like for the just first 3 terms, right? We want to prove the general one, we need to use the general terms. Okay, so you are. So let's say if you get the common ratio, okay, when you get the common ratio, then when you have the common ratio, you have the number of term. You can find the first term also, right? Okay, you have the first term, you have common ratio, you can use the formula for geometric series to find the sum of first n term. Then, of course, if you have the sum of first n terms, over here it says that deduce. Deduce means it doesn't want you to directly apply the formula for sum to infinity. So how to deduce? If you have the sum of first n term, you want to find sum of infinity, is actually limit n to infinity for the sum of n term. Okay, you can get the sum to infinity. Okay, so remember, there is one thing that is very important that for you to be able to figure out which method to use is you know that there is only 3 methods to use. Okay, arithmetic series, geometric series, and method of difference. So if you are only these three methods to use, you are more confident that, okay, you must know how to do it, okay, because if you didn't confident that there is only these three methods, you will feel that, there might be other method and you didn't try to figure out which method is it, then you just skip the question, okay. But for this question B, it's actually quite easy. It's actually geometric series, but just that whether you got figure it out or not, okay. So for this question 2, convergence sequence is defined by this. So this is what? This is actually a recursive formula, okay? So when you use a recursive formula, they must give you the first term. If there are no first term, you cannot find the, okay, the next term, okay? It must have one first term over there. Okay, so write down each of the statement U2, U3, U4, okay, in the form like this, okay. So this is just, it want you to express, you just try to you have U1, you use the formula to find U2, to find U3, to find U4. Then what does this mean? It just means that you write the formula in terms of the power of 1 over 3, okay. Summation of 1 over 3 power k. It means that the form should be something like this: 1 over 3 power 0 plus 1 over 3 power 1 plus 1 over 3 power 2, okay. He want you to express it in something like this, okay. So if you try to add, you manage to get something like this. Sorry. Okay, show that the sorry, show that an explicit formula for UR is given by UR the lead equals to this. So if you try to expand it, okay, try to expand it in terms of this, you will find that it is actually, okay, a sum of geometric series, okay, because it is something like this, where it is sum of something like this, okay. This is actually geometric series, right? Because the ratio between each term is actually 1 over 3, okay. So if UR is something like this, then UR is actually a geometric series, the sum of a geometric series. So you can directly apply the formula for geometric series, okay, sum of geometric series, then you can get this formula, okay. It's actually quite straightforward, okay. Determine the limit of UR as R tends to infinity. Actually, this is, okay, it wants you to find limit of R towards infinity, okay, UR, okay. So you sub this formula inside. Okay, let's say you don't know how to do question A, but you know how to do question B. Can you do question B? You must, if you know how to do question B, then you must go to do question B, okay? Because even if you cannot do the front part, but you can do the second part. Over here, it already provides you the formula for UR, right? So you actually should be able to proceed to part B, even if you didn't do part A. So if you can do part B, you must do the part B for it, okay? So it just limit of UR as R tends toward infinity. So you have the formula of UR. You just limit R to infinity, okay? You should do this, okay? If you know how to do this, it's, even if it is 2 marks, but it is easy, you should do it. Okay. So if you try to limit this, okay, you try to limit this, you actually get this 1 over 3 power R. When you have a fraction that are less than 1, you limit it to infinity, you keep, it means that you times it infinity times, okay? 1 over 3 minus times 1 over 3, you will get a smaller number. If you times it many times, it will tend towards 0, okay? So this number will tend towards 0. So if you limit R to infinity, you will get 3 over 2 times 1 minus 0, okay? Which is 3 over 2, okay? So if you see the next year, 2017, the sum of the first n term of the sequence U1, U2, U3 is given by Sn equals to this. Find an explicit and a recursive formula for Un. How to do? It gives you Sn. This is another type of question. Okay, I try to teach you. If you have Sn, you want to find Un. It's actually very easy. The formula is Un equals to Sn minus Sn minus 1. Okay, remember this formula. Okay, how do we know this? Okay, so if we have Sn, it means we add up, okay, U1 plus U2 plus U3 plus dot 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 plus UN minus 2 plus UN minus 1 plus UN. This is Sn, right? Sum to the n term. If we have Sn minus 1, then it will be U1 plus U2 plus U3 plus dot 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 plus until UN minus 2 plus UN minus 1. Okay, it's sum until the n minus 1 term. So I say that Un equals to Sn minus Sn minus 1. It's just if you get Sn, okay, minus Sn minus 1, the whole front part will minus up and you just left out with one Un. Okay, so this formula is actually quite straightforward, okay? Just that you can see it or not. So if you have the formula of Sn, you can find Un, okay, by using the formula Un equals to Sn minus Sn minus 1. Okay, so if you have Sn, you can solve it. Okay, sorry, it's the previous question. Okay, so Sn, okay, sometimes we don't know how to sum the Sn minus 1. Okay, I try to teach you. Un is Sn is just straightforward minus, okay, Sn minus 1. The part that is previously n, you change it to n minus 1. So if this n is being squared, then this n minus 1 should be power 2 also. Okay. Okay. Then you try to simplify it. Okay. For this, if you try to simplify it, if we want you to show it in a recursive formula, normally it should be in arithmetic progression or geometric progression. Okay, or else it's very difficult for you to do it. Okay, so when you show this, it should be an arithmetic progression. Okay, so if you find out the formula, you can try two ways. Okay, to express it in a recursive formula, you can try two ways. Either you find that the difference in the terms is a constant, or you find that the ratio of the terms is a constant. You try the two ways. Okay, mostly it should ask you these two ways only. After you try, if it is not the first way or also it is not the second one, then if you still don't know how to do, then just skip the question. Okay, but at least you tried. Okay, better than you didn't try. Arithmetic progression or geometric progression only. Okay, normally. Okay. Okay, then 2018. The sum Sn of the first n term of the sequence is this, given by this. Show that Un equals to this. How to do? Similar type of question. No? If it given you Sn, it want you to find Un. You use this formula, Un equals to Sn minus Sn minus 1. You should be able to simplify it until this question, this part. Okay. Okay. So if you are not able to simplify until this, you still be able to do part B because you have the formula of Un. You can find Un plus 1 in terms of Un. So Un plus 1 in terms of Un, what is this? This is actually the recursive formula. So I say that recursive formula, there are only two types, right? Either is arithmetic progression, it will ask you to find the recursive formula, or geometric progression. If it is arithmetic progression, we find the common difference. If it is the geometric progression, we find the common ratio. If you are not sure, you can try both ways, okay? But over here, it is actually a geometric progression. So we use the common difference method, okay? So we use Un plus 1 over Un equals to, okay, some common difference. If you're not sure, you just directly substitute this formula, 8, 3 minus 2, n plus 1 over 8, 3 minus 2n, okay, sorry, then try to simplify it. Okay, let me try it out. Okay, this you should get 3 minus 2n minus 2 over 3 minus 2n. You will get 3 minus 2. Okay, so un plus 1 over un equals to 3 minus 2, which is a constant. Okay, so un plus 1 should be equal to 3 minus 2 un. Okay, so when you express in the recursive formula, you must give it the first term. Okay, you must give it u1. If you didn't give it u1, you didn't get the full marks. Okay, so un is this. You want to find u1. U1 is actually just 8 times 3 power negative 2 times 1. Okay, you can get this answer. Okay, 8 over 3 square. Okay, 8 over 9. Okay. Okay, just give it the first term so that it can proceed to find the next term. Okay. So deduce that the sequence is geometric sequence. So if you are able to find this, you show that this is a constant. Over here, you can deduce that it is a geometric sequence, right? Because the ratio of two terms is a constant. Okay. Find the sum of infinite series. So just now you find the geometric sequence. You show that it is a geometric sequence, then if you sum it up, it is a geometric series. Geometric series, we have one sum to infinity formula, right? So over here, you just directly apply the sum to infinity formula, okay? Or else you can use a different method. Sn, S infinity, or normally we call S. Okay, S means sum to infinity is equals to limit n tends towards infinity 1 minus 3 power 2 power n. Okay, limit sum of n towards infinity, you will get sum to infinity. Okay, normally they didn't write sum to infinity. They just write the big S to represent sum to infinity. Okay, we will try to. There are still a few questions. We will try to discuss, finish it. Okay. So at least now we have some basic idea, right? Question 2 is not is question 2 is solvable, okay? Just we need to know the trick and how we should enter the question. So for 2019, it asks you to find the sum of first n terms of the sequence, okay, given by this. Okay, excuse me. So when it gives you the sum to the n term, you know how to find the un term, right? Okay. So find an explicit formula for an, the n term of the sequence. Now it use a, okay, but actually it's the same. So the n term is just, we use the formula un equals to sn minus 1. If you know this formula, you can obviously very quickly found the explicit formula for it. Then determine whether an is increasing as n increases. Okay, this is the more difficult part. Okay, you might not be able to do this. Okay, you might not be able to do this. It is okay if you're not able to do this. Don't stuck to it. Just try to skip to the next part. Okay, if you are not able to do this, don't stuck to it for too long. Okay, I will tell you how to do this later. But if you really is not able to do this, you can just skip to the next part. Okay, so B, show that the series is an arithmetic series. Okay, if you want to show that the series is an arithmetic series, you just how to do? Find a common difference. Okay, we find the common difference. If you are able to find a common difference, okay, if you are able to find a common difference, then you can show that it is an arithmetic series. Okay, so we're back to the question: whether an is increasing as n increases. How do we show this? Okay, actually, it's still the arithmetic things. Okay, you show the common difference. Let's say if you found an, okay, if you found the formula of an, either you use an plus 1 minus an, okay, or an minus a or an minus 1 is actually the same. Okay, you find the difference between two terms. Okay, so this is the next term, this is the previous term, right? You use the next term minus the previous term, you should get some constant, positive constant value. Okay, because later you'll find that it is arithmetic series, right? The common difference will be, okay, the common difference will be a constant. Okay, so an minus an plus 1 minus an, you found that it is a positive constant. Okay, to show that it is greater than 0, it means that an is increasing as n increases. Why so? Okay, because if you found that an plus 1 minus an is a positive, it means that, okay, it means that if you always get the next term to minus the previous term, it is always the next term is greater than the previous term. So if the next term always greater than the previous terms, then as n increases, an should be increasing, okay? So that the next term always is greater than the previous term. Okay, so we show it by this, okay? So sometimes it came out some special question that we didn't see before. So our target is not to stuck to those special questions, okay? We want to solve those things that we already know how to do. For example, how to find explicit formula for an, okay? This we can do, right? Show that the series is an arithmetic series. This one we can do. This one, if you really don't know how to do, try to do something, if or else you just directly skip it, okay? Don't stuck to the question for too long. If you stuck to this question, you might lose mark for those questions that you already know, but you don't have time to do it, okay? So we check 2020. Okay, expand this in ascending power of x up to the terms in x cubed. Find the range of value of x such that the expansion is valid. Okay, so for this question, we also need to know how to do it. You see, all the previous question, it came up the series question, right? Until 2020, it came up the question for the binomial expansion. Okay, so for expansion question, in your level, you only know binomial expansion. You don't know other expansion. Only if you go to your Sem 2, you know how to do other expansion. But during your Sem 1, you only know binomial expansion. So you don't think of other expansion, okay? Don't think of other formula. When you see expansion, you must recall you only know binomial expansion and use binomial expansion to solve it. So how to do this? If we want to do binomial expansion, we need to express it to, okay, the form like how we wrote just now, okay? So it has the form like 1 plus something, right? Okay, we can try to apply this formula. So this one can be written as 1 minus 3x over 1 plus 2x equals to 1 minus 3x power half times 1 plus 2x power negative half. Okay, if you are able to write it in this form, you should be able to apply this formula. Okay, so this negative, okay, maybe you still can't see the formula. You can do something like this: 1 plus negative 3x, 1 plus 2x. Okay, so later, okay, you get the formula over here. You get the formula over here. It says that it wants you to expand up to the formula in terms of x cubed, right? Then this one you expand until x cubed. This one you expand until x cubed. Later you times up. You multiply them together. You only write the terms that they are up to x cubed. If you get x4, x5, x6, you didn't need to write it. Okay. Okay. So you can try to do this question by yourself. Okay. I believe that you might be sorry. I believe that you have tried before. Okay. This is quite common question. And this is like until so many years, the only past year that came out that asked you about the binomial expansion your teacher should ask you to do before already. Okay. So find the range of value of x. Okay. How to do this part? Such that expansion is valid. Okay. You must know how to do this. This is also one quite important things. Okay. So if you use the binomial expansion formula, the binomial expansion formula has one condition. Okay, has one condition. If you use the binomial formula for this one, it has one condition, which is the x. X doesn't mean the x in the question. X mean the 1 plus thing. Okay, the thing over here, the whole thing over here this thing must be between -1 and 1. Okay, this is the rule. Okay, the x must be between -1 and 1, else it cannot use this binomial expansion. Okay, so if you want to use this 1 plus x power n formula, you must ensure that this x over here, okay, this thing over here must be between -1 and 1. So how do we apply this? Okay, just now you apply for this thing, right? So for this previous part to be true, your -3x must be between -1 and 1. For the behind part to be true, your 2x must be between -1 and 1. Sorry. Okay. So if you want both to be true, you need and or. You need and, okay? You need this to be true and this also true. Both true only, both formula also can work. Okay. So from here, you can find that x should be, okay, -1/3 and 1/3. From here, you found that x should be between -1/2 and 1/2. If you want both to be true, then you need to find their intersection, okay? So their intersection should be, okay, their intersection should be -1/3 to 1/3, okay? Because this is the smaller range, okay? You need to find their intersection, okay? So this should be the final answer, okay? So if you're not sure how to find the intersection, you can try to draw a number line. So this is -1/3, -1/2, 1/3, 1/2. Okay, so one say that it should be between -1/3 to 1/3. Another say that it should be between these two. So the intersection part should be this part. Okay, that's why the answer is this. If you don't know how to do it, you can try to draw the number line. Okay, so 2021. This question is actually very difficult. A sequence U1, U2, U3 is defined by a recursive formula like this. Okay, where R greater than 3, greater or equals to 3, and U1 equals to P, U2 equals to Q. Show that this and this. Okay, we might not be able to do the behind part, okay? If you want to find part B, you need to find the formula first. Before you find the formula, you cannot do part B. So what is our target? At least you try to find 1 and 2. Because for 1 and 2, you just try to sub the formula, right? You just try to sub the formula. So you just try to sub the formula, okay? You just try to sub the formula, then you will what? You will you can try to simplify until this formula, okay? If you try to sub the formula, you can try to simplify until this form. Okay. So we should be able to get these 2 marks, okay? And hence find the explicit formula for un and u2n minus 1. Okay. What is 2n and 2n minus 1? 2n actually means even number. 2n minus 1 actually means for odd number. Okay, for odd number. So over here we have even number terms, right? We can try to find for u2n. Then later you can try to find for odd number, okay? So let me explain this question. If you want to find the number of the formula, okay, explicit formula, you need to recognize the pattern. So this one is actually, this one is actually u2 times 3, okay? This one is u2 times 4. Okay. So how do we use, okay, when you want to express in explicit formula is different from recursive formula. Recursive formula, we want to express it in terms of the previous term. If you want to express it in explicit formula, you express it in terms of the number n, okay, inside the formula. We try to express it in terms of the number n inside the formula. Where do we see the number n? Actually, you can find over here. You can relate this power 2 with the number n. Okay, let me try, okay? For this, 2 power 2 should be able to write as 2 power 3 minus 1, okay, times q. Minus 2 power 3 minus 2 times 7, okay? Over here, the 7 didn't times anything. Okay, if it didn't times anything, it's actually times with a 1. So you can write as 2 minus 3 minus 3, okay, times 7. Okay, now we see some pattern already. For this one, 2 power 3, you try to relate it with the number of n. So over here, it should be 2 power 4 minus 1 times q. Then minus 2 power 4 minus 2 times 7 minus 2 power 4 minus 3 times 7 until, okay, sorry, I try to rub a little bit off. Okay, until negative 2 minus 4 minus 4 times 7. Okay. So if you try to write the formula for u2n, okay, I try to write over here. If you try to write the formula for u2n, you should get, okay, at least you can find the first term is 2 power n minus 1 q, right? Okay, because it's always like the n minus 1, okay, it's always the n minus 1 that times to the q. Okay, after that, for the behind terms is a little bit more difficult. But you found that for the behind term, they are all common terms 7, right? Okay, okay, maybe we didn't write the term 7 out yet. We try this up. Negative, okay, 2 power n minus 2 times 7 minus 2 power n minus 3 times 7 minus dot 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 until 2 power 0, 7, right? Okay. Okay, so we actually can factor negative and 7 out. So negative 7, we get 2 power n minus 2, okay, plus 2 power n minus 3 plus, okay, plus dot 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 until 2 power 0. Okay, so what is this? This is actually geometric, okay, geometric progression. Okay, this is actually geometric progression. So we can use the formula for geometric progression, sum to the how many terms? You need to count the correct number of terms out so that you can use the correct formula. Okay, so here actually we have n minus 1 term. Okay, here we have n minus 1 term. Okay, we have n minus 1 term because it starts from 0 and it count until n minus 2. So you use sum to the n minus 1 term formula, okay, as n minus 1. Okay, so if you apply as n minus 1, you should be able to, okay, simplify this further to a simplest formula, okay. Then you will get the answer, okay. I will not show you this, you can try it yourself. Okay, you can just simplify it. Okay, then you can do the same thing for u2n minus 1, okay, for the odd number part, okay. So this question is actually quite difficult. So let's say if you are not able to do this, at least, okay, at least you must try the part 1 and part 2, okay. Okay. Given that the 18th term of the sequence is 137 times the 5th term of the sequence, express q in terms of p. So let's say if you manage to get the formula for the previous part, then how to do this? Okay, this is actually like the marks for those who are able manage to get the previous part. Then they say since you try so hard, I give you 2 more marks. Okay, so if you are able to do the previous part, this is actually quite easy because you just try to write out what it says. Okay, so the 18 terms is equals to 137 times of the 5th terms. So if you have the formula of u5 and you have the formula of u18, since you already find the u2n terms and u2n minus 1 term, you should be able to write out both equations, right? Then you just solve for what? Solve for you want to express Q in terms of P, okay? You just solve for Q in terms of P, you can get your answer, okay? You should get your answer if you are managed to find the previous things already, okay? So for 2022, okay, determine the value of P and Q such that this thing equals to this, where P and Q are constant, okay? Hence, find of the first n term of the series. Okay, actually for this, the P plus Q, one used to express this in partial fraction, right? Okay, this one is partial fraction. After you express it in partial fraction, you should notice that it is actually the Q should be negative, okay? This should be the difference of two terms, okay? If it is the difference of two terms, then later you want to solve this, okay? It says hence, right? Hence it means related to the things before, okay? So over here, one of the terms should be, okay, should be equivalent to this formula, okay? So you write the formula for this, okay? Should be, okay, QR equals to 1 over 3R plus 1, okay, 3R plus 4. So when you sub R equals to 1, you will get 4. R equals to 1, you will get 7. Okay, so you actually get the same thing as this, okay? So actually it's the sum of this UR term, okay? So we can rewrite this as sum of UR from R equals to 1 until the n term, okay? Then you use the method of difference. When you use method of difference, you express your UR in the difference of two terms. Okay, then we cancel it out, right? Okay, you must know how to do this. Okay, so even we say that the method of difference is very important, but actually it's come out quite less, okay? This is one times and another times is actually over here, okay, 2023. But it's still very important, okay? You must know how to do this, okay? So you can write in different in two terms, okay? Then cancel out. Yeah, I can show you some example of question. Okay, so chapter 2. Okay, how we do the difference of two terms, we do it like this. Okay, let's say just now we managed to express this as sum of R equals to 1 until n UR. So we sub the UR as the difference of two terms. So when you sub it as difference of two terms, there are some trick that we can easier to see the pattern, okay? If you want to easier to see the pattern, the better way is when you sub the 1 inside, you don't write it as 1 plus 1, then 1 plus 2. Then here you write 2 plus 1, 2 plus 2. It is difficult to see the pattern. What we want to do is, if let's say you already sub it like that, but you write it again, okay, you should write it again in the add up form, okay, like this. So you didn't show that it is 1 plus 1, you straight write the number 2. You didn't show that 1 plus 2, you straight write the number 3. Okay. When you add it up, it is easier for you to look at the pattern. Okay. You can see that, okay, this is 1 over 3, this is 1 over 3, you can cancel it out. This is 1 over 4, 1 over 4, you can cancel out. Okay. So the cutting pattern should be consistent. Okay. So if you cut it at this angle, every term behind should be cutting using the same angle, okay, until the last part, okay. So this is the thing that is left out. Okay, so there is one thing that I want to remind you of, that always until now, I still see everyone is doing the same wrong thing, okay, which is this bracket. When you wrote it in difference of two terms, always, all of you don't like to write the bracket. But I want to remind you, if you didn't write the bracket, the sum is only applied for the first term only. It didn't apply for the second term. Even if you know what you are doing, but you didn't write this bracket to bracket the two things, you are doing it wrongly, okay? The marker can deduct marks over here. So you must remember that to put bracket over the whole sum. If you didn't put the bracket over here, it assumes that you are doing sum of this and this one is not being summed. Okay. Okay. So 2 more questions. Let us quickly glance through and we can proceed to chapter 6. Okay, so question 2. Expand this in ascending power of x up to x cubed. State the range for value of x which expansion is valid. This is similar to the one before, right? So this one quite easy. If came out something like this, okay, we must know how to do. So this one you can write it like this. So if you are unsure, you can write it like this. Plus, okay, negative x. Okay, then you expand this, both up to x cubed, then you multiply them together. You only need to write down the terms that are until x cubed only. Okay, then how to state the range of value of x which expansion is valid? If you want the expansion to be valid, you need to fulfill the rules that the 2x over here must be between -1 to 1, and because you want both also valid, so you must use and. Okay, you find an intersection. -1 until -x must be in between -1 to 1. So you solve this, you should get -half. Okay, less than half. This one should get the same thing. Okay, because and you can draw the number line and find the intersection. The intersection should be, okay, the intersection should be this one, okay? If you are not sure, you can draw the number line. Okay, so 2023 is quite straightforward. Then now over here is 2024, which they say that is the most difficult year, okay? Last year, because very less people get A. So what happens if you are the student who take this exam? What should you do? Okay, we should think of what we can do. So when we want to try this question, you get UR equals to this. Okay, simplify UR plus 1 minus UR. Can you do this? We can, right? You should do this first. Okay, so you try to do this, should be able to do this, right? Simplify, blah, blah, blah. Okay, you should get some simplification form. This can be done. Okay, everyone agree, right? Okay, find the n terms of the sequence. Okay, over here, what is the n term of the sequence? If you notice, what sequence we have learned? We actually learned the arithmetic and geometric sequence, right? So this, you check out, okay, is arithmetic or geometric? Okay, it's actually a arithmetic sequence, okay? So is arithmetic sequence, then you know the formula for arithmetic sequence, right? You can quickly write out the formula for arithmetic sequence. Why we always feel that the question is difficult, because we always feel that it is something that we didn't learn before. But you must recall yourself, it is something that we already learned, but it show it in different form so that to trick us, we need to relate it to what we have learned. Okay, relate to what you have learned. So it's actually just arithmetic progression. If you know that it is arithmetic progression, you remember the formula, you can quickly write out the formula for the n term. Okay, so this 2 marks is actually quite straightforward. Okay, so now evaluate this thing. Okay, this is the difficult part. If you don't know how to do, what should you do? If you don't know how to do, you should skip to the next question and do what you can do. Okay, not stuck to this question and then the whole behind part you does not manage to do anything. You just start over here for 1 hour, then you didn't do the behind part. Okay, so what you should do is, you found this difficult, just skip to the next question. Okay, complete what you can do first. Okay, you don't even have time to complete what you can do, so don't stuck to the question that you don't know how to do. Okay, it's okay to skip the question. Okay, even if you lost like about 15 marks, you still should be able to get A. So if the question is difficult, then you have a higher chance to get A lah, okay? So you remember your trick. Don't stuck to the difficult part. Do what you can do, then skip to the next question. After you complete the whole paper for what you can do, then only you come to found which part that maybe most interesting to you, then you continue to solve that part, okay? Okay, so how we can try to deal this question. Okay, you see, this one is actually the first term over here, right? Okay, this one is the second term. This one is the third term. Okay. In front of it, it times with the number of terms. So if let's say, okay, we try to write out this formula for UR. So UR over UN, okay, is it want the number of n terms. Okay, so UN should be equals to A plus n minus 1 D. Okay. So if UN equals to A n minus 1 D, you get 4 plus 6n minus 6, and you get 6n minus 2. Okay. So evaluate this thing. Okay, this thing, if you want to evaluate it, you find the number of terms. Let's say I let the number of terms over here be T. Okay. So Tn should be the number of terms n times with UN. You notice it, right? It's just the number of terms times with the terms over here. So Tn is actually n times UN. So it's n times 6n minus 2, which is 6n squared minus 2n. Now, if let's say we want to find the sum of these, okay, sum of this is the first term until the 100th term. So sum of this is n equals to 1 until 100 Tn, which is sum of n equals to 1 until 100, 6n squared minus 2n. Okay, so this is equivalent to sum of n minus n equals to 1 until 100 n squared minus 2 times sum of n equals to 1 until 100 n. Okay, at least you can do until here, okay? Okay, how to do these two? Okay, actually these two we have the formula. For this part, it is actually arithmetic progression because is sum of n equals to 1 until 100 is actually 1 plus 2 plus 3 plus 4 plus dot 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 plus until 100. Okay, this one you should be able to solve it. How about this part? Okay, this part is more difficult. Okay, this part you need to remember the formula. This one, the formula is this. Sorry. Okay. If you didn't remember this formula, you might not be able to solve this. Okay. So the formula for sum of r equals to 1 until n is half of n times n plus 1. Okay, sum of r square should be this one. Sum of r cube should be this one. You all should memorize this formula. Okay. If you didn't memorize, you will not be able to do this. Okay. But of course, there are only 100 terms. Okay. If you want, you can use your calculator to sum up until 100 terms. I'm not sure if you do like that, you can get the marks or not. Okay. But at least you try. Okay. At least you try, because just 100 term, but you can 1 plus 1 square plus 2 square. Okay. Actually, you can use your calculator to use the formula of sum 1 until 100 for n square. But I'm not sure it will give you marks or not. Okay. But at least you try to do something until here, then you will get the marks for the method until this part. Okay. But the final marks, if I'm not sure how they calculate, you might not be able to get since you didn't use the correct formula. But since here is only 100, I'm not sure if you try to add up, you can get the marks or not. Okay. But okay, this is the most part you can do. Okay, until here. So if you apply the formula, you should be able to get to get the answer. Okay, to get the answer. So over here you should apply the two formula, then you will get the final answer. Okay. So I'm not going to discuss the section B, okay, because it's actually come out quite less. I will proceed to the vectors. Okay, so let us take 5 first. We come back at 10:30, then we continue for the vectors. Okay. You can go to the toilet or go to drink some water, eat anything. Okay, we come back at 10:30. Okay, then later we discuss a little bit about this, then look at the past here. Okay, so now we want to continue for chapter 6. Okay, that over here is actually some short notes okay I made for you guys. I take from my previous intensive notes, then try to add something okay. I modify this a bit, add this diagram, modify a bit. Okay. Then rearrange a bit. This one is the new part. Okay. This one also new one. I just add this in. This one also the new one. I just add in. This one is the same as before. This one also the same. I didn't change. Okay. So there are many possible questions. Okay, but common type of question I already like try out. Okay, I try to find, then I write out the method and summarize over here for you. Okay, so let us let us look a little bit on how we need to deal with the vectors. Okay, so there are two types of vectors: two-dimension vectors, three-dimension vectors. So in our syllabus, normally we deal with 3D vectors. Okay, so we can write it in terms of x, y, z. Okay, we say that Cartesian form or the component form. Okay, component form is actually actually the matrix form. Okay, normally we write it in the matrix form. Then for magnitude, if you want to calculate magnitude of a vector, we'll use this formula. Okay, just memorize this formula. Then we also need to know how to calculate unit vector. Unit vector is actually the vector plus a hat. Okay, we call it cap. Okay, so you will find that sometimes like this is a unit vector. When you bold some symbols, it means that it is a vector. By bolding, putting an arrow or putting a tilde means this, okay? Or you bold it. Normally, because when we write, we cannot bold something, right? So bolding is only your textbook can use, okay? If you want to use bold to show a vector, you cannot. So what we will do is we write an arrow. So we either put a tilde, an arrow, or if for books, they can bold it. So when you have a vector, then you have a cap on it. It means unit vector. Okay, you cannot put something like this. Okay, it doesn't exist. Okay, this is the wrong symbol. You need to be a vector, then only put a cap. So for this, why they don't need to put arrow or tilde, because they bold it. Okay, so they bold it so they can directly put the arrow. Okay, so unit vector is just the vector divided by its magnitude. Okay, so the magnitude of unit vector is 1. Where is 1? Okay, so we have two types of product of vectors. First type is dot product, another one is cross product, right? Okay, you need to know that after you do the dot product, it get a scalar quantity. If you do a cross product, you should get a vector. So you need to know how to perform dot product and how to perform the cross product, okay? So normally what we can do is for dot product, normally when you say that two things are 90 degree to each other or perpendicular to each other, then we will use dot product to show that they are 90 degree. If two vectors are 90 degree, then their direction vectors, when you dot together, they will equals to 0. Okay, for dot product, only parallel terms are multiplied together. If there are 90 degree terms, their multiplication will be 0. Okay, for cross product are opposite. They only multiply the 90 degree vectors. If you have parallel vectors, the cross product of parallel vectors will be 0. Okay, but normally we seldom use cross product to show something are parallel, okay? But we use dot product to show that two vectors are perpendicular. Okay, so it's very common that we deal with question that ask about lines and plane, right? So we need to be very familiar with equation of line and equation of plane. Sorry. So if you want to find the equation of straight line, you need to know two things. You need to know a position vector and a direction vector. So position vector is something like this. We call it A, and direction we call it B. So position vector, it locates one point on this, okay, on this line. After you locate one point on this line, you just add any vector that are along the line. We call it direction vector. Okay, so the direction vector, you can elong it uh, as long as possible, or you can change the direction. So when you change this B vector, you can make it longer, okay, to point towards a point that are further, or you can change the direction to opposite direction to point it over here, okay? So that's why our equation is A plus lambda B, okay? So the lambda here is a scaling factor that scale this B up. It can make the B shorter or make the B longer to which position that you like, okay? So the vector R is actually some random vector R, let's say over here, okay? A plus lambda B will equals to R. This is the R vector, okay? We want to know this R, the position vector of some point, okay? So if your R is over here, if your R is over here, then your R is A plus, let's say 1.5 B, okay? So your R, this R is equals to A plus 1.5 lambda B. The R is also the position vector of this point. Let's say this point is R, then your R is actually equals to OR, okay? The position of this point R. So this can be any point on the line, okay? If you want to find the equation of any line, you want to find the position of any point on the line, you just need to find the lambda, the correct lambda, then you can find the coordinate of it, okay? So this is just example of one point, okay? So let's say sometimes they didn't give you the direction vector. What they can do is they give you the coordinate of 2 points, let's say A and C, which lies on the straight line. So if they give you the coordinate of this point and this point, but they didn't give you these two vectors, okay, if you have the coordinate of A, actually you already have the vector A. So let's say if you have coordinate AS, A, B, C, okay, let's say, then your vector A is actually position vector of OA, which is position of vector of OA is this put at the component, okay, ABC. Okay, then how about direction vector? If you need a direction vector, you just need a vector that is any vector that is parallel to the line. So if you have 2 points that is parallel to the line, then you can say that AC is the direction vector. How to find AC? If you want to find AC, you can think of that C also has a direction vector. You have AC, you have OA, you have OC. You want to find AC equivalent to you from A move to C. You can move straightly from A to C, or you can equivalently move from A to O, then you move from O to C. If you move from A to O, then move from O to C, you will get AC, okay? Your B should be equals to AC, should be equals to A to O plus O to C. A to O is actually equivalent to negative OA, okay? Negative OA plus OC. So if you negative OA plus the OC position, you should get your direction vector B. Okay. So if they directly give you A and B, then it's the best. Okay. They directly give you the position vector, give you the direction vector, then it's the best. But if they didn't give you, they give you the 2 points, the coordinate of 2 points, then you need to do some modification and get the A and B vectors. Okay. Okay. So let's say today you get your vector A and vector B. If they ask you to write in the vector form, the vector form is actually just R equals to A plus lambda B. Okay, so you put your A inside here, you put your B inside here in the matrix form, you get your vector form. Okay, of course, you can write it in the I Cartesian form, which you write in I cap, J cap, Z cap. But I think that that method is more messy. Okay, so normally we write in the component form. Okay, so for Cartesian form of the equation of line, we write like this. How do you see something like this? Okay, actually, you need to know the parametric form first. The parametric form is actually this equation. You get this. Okay, this equation, the R actually is the coordinate of some point, any point on the line, right? So if you don't know the coordinate of any point on the line, I call the coordinate as x, y, z. So xa means the coordinate of x coordinate of a lah, okay? Xa, ya, za. So this plus this, you should get something like this, okay? So you equal these two matrices, you should get your parametric form, okay? X equals to xa plus lambda b, y equals to ya plus lambda b, okay, and so on. So this is the parametric form, okay? You directly get the x, y, z only. Okay, so if you have the parametric form, you can solve for the lambda, right? From here, you can get that lambda equals to x minus xa over xb. From here, you can get that lambda equals to y minus ya over yb. From here, you get that lambda equals to z minus za over zb. So all the lambda should be equal. So if all the lambda should be equal, then all these things should be equal, then you get this equation. So this 3 is equal and equals to lambda, but we didn't write the lambda, okay? We just write this 3 is equal. This is our Cartesian form. So you notice that you can, from the Cartesian form, read out the xa, ya, za. You can read out the xb, yb, zb. Okay, you can straight directly read out from here. Okay, so you need to realize that over here is the negative, okay? You need to put a negative, then only over the reading and read over here is the position vector. Okay. Okay, so what you need to know is you need to know how to interchange between those forms. This is what the basic things you need to know. And you need to know how to read out the position vector, how to read out the direction vector. Okay, let us proceed to the plane. Okay, so if you need to know the equation of plane, you must know two things. The first thing is the normal, okay, normal to the plane. And the second thing is the position vector of some point A lies on the plane. Okay, so if let's say you have some position vector A lies on the plane, then you can just, okay, the vector form is r dot n equals to a dot n. Okay, so I'm not going to derive this for you over here, okay? So you just directly memorize this, r dot n equals to a dot n. Your a dot n, because you know a, you know n, then a dot n should get a number, okay? This number is m. So normally we dot this out and we get this number m. Okay, we just write it as a constant value. So r dot n, the n over here, you remain as the vector form ABC. This r, you remain like this, okay? Equals to m. This is the vector equation. So what is Cartesian form? Cartesian form actually come from this. So your r, I say that is actually the any point on the plane. So if you don't know the coordinate, I call it x, y, z. You dot it with a, b, c equals to m. After the dot product, you should get ax plus by plus cz equals to m. Okay, So this is the Cartesian form. Okay, so there is actually another one seldom used form called parametric form. Okay, so if you want to describe the plane using parametric equation, you can do something like this, similar to the equation of the line, but equation of line, you just need one direction vector. For plane, you need two direction vector, because for plane, if you just have one direction vector, it will only go in one straight line. If you want to explore the plane in two dimension, you need at least two vectors that are not parallel, okay? Two direction vector that are not parallel, then only you can explore the whole plane, okay? So it's some position vector plus lambda first direction vector plus mu second direction vector, okay? So let's say if you have 3 points over here called A, B, C, they give you 3 points, then you can use OA as the direction vector, AB as the, OA as the position vector, then AB as the one of the direction vector, BC as another direction vector. Even if you want to use AC as another direction vector is also okay. Okay. So sometimes let's say if you want to find the vector form, but they give you 3 points on the plane. They didn't give you normal vector, they didn't give you position vector. Okay. So if the coordinate of 3 non-collinear points A, B, C, which lie on the plane is given, okay, then your position vector can actually be any of the 3 points, okay? Let's say I choose A. So direction vector is OA. Then your normal vector, if you recall, when you cross product two vectors, you will get a vectors that is normal to both of them. So you just use AB cross BC, you will get a normal vector that is normal to both of them, okay? So when the normal vector is normal to both AB and BC, it's actually normal to the plane. So we can use this method to get normal to the plane. Okay, so we first find the position vector and find the normal to the plane, then we can proceed with the same method to find the vector form or Cartesian form. So you should also be able to read out the normal vector from the Cartesian form and also read out the normal vector from the what? Vector form, okay? And you should be able to know how to interchange between these two. But this one, we seldom use it, okay? But it still come out in the past year, but very seldom we'll use some form like this, okay? You see, in 2015, it got give something like this, okay? But it seldom come out. Okay. So here got some formula that you can use, like find the area of triangle, find area of parallelogram. This one you should memorize, okay? So like how to find a vector that's perpendicular to plane ABCD, you just use two vectors, cross product, you will get something that is, okay, a normal vector. Okay, so over here you can look at yourself. Okay, here is some showing things that sometimes they will ask you to show that something, which one is collinear, which is parallelogram, which is rhombus, which is trapezium. Okay, you can read it yourself. Okay, but this one I want you to focus more. How to show that two pairs of vector are orthogonal. Orthogonal means that they are perpendicular, okay? Sorry. If you want to show that the two vectors are orthogonal, then you use dot product. Just now I said that if you dot product two perpendicular vectors, you will get 0. So R1 dot R2, you actually get 0 if they are perpendicular. You can use this method to show that two vectors are perpendicular. Okay. So here are some interesting questions that they might ask and you mostly don't know how to do. So for the first part, how do you find the shortest distance from a point to a plane? Sorry. Let me drink some water first. Okay. So if you have a point and you want to find the point to the plane, okay, the shorter distance from the point to the plane. So actually, you can find multiple different distance, but they are not the shortest distance. The shortest distance is where, when you connect P to the plane, you'll find that it is perpendicular to it. Okay, this distance should be the shortest distance. how should we find this shortest distance? I have checked and I have found that there are there are 4 common methods that we use. Okay, so I'm not sure which method that your teachers taught you. So I just write out all 4 methods. Okay, so you can compare and choose the one you like. Okay, of course, the first and easiest method is which I uh saw it from the As Ahead book. It just directly apply the formula. So if you want to memorize this formula, then you can directly get the this shortest distance. Okay, but I'm not sure whether this one can get the full marks or not, because this one just directly apply formula. So if the question just 2 marks, then this one should work out. Okay? If the question is like 5 marks, then we don't expect you to just directly apply the formula, right? Right, okay. So if you look at the question, if just 2 marks, then don't think too much. Apply formula should be able to get the marks. But if like 4 or 5 marks, try to do more things. Okay, choose any 3 of the method below. Okay. So there are 2 cases, like, because mostly they won't just come out one question like this one. They will have part A, part B, part C. So if the previous question, let's say if the previous question gave you some other points on the plane. Let's say A, sorry. Okay, let's say in the previous question, you managed to find some point A on the plane. You don't know where the point is, but you know the coordinate of point A. Okay, but if you find AP, or maybe they ask you to find AP, P is the point that they want you to find the shorter distance to the plane itself. Okay? So if let's say you manage to find this AP, this is not the shortest distance. Okay, this is just some distance longer than the shortest distance. The shortest distance must be, okay, perpendicular to the plane. But if you have this AP, you actually can manage to find the shortest distance very quickly. So let's say AP is PQR. So let's say you found this vector AP. AP is this vector. Okay, let's say you found this vector as PQR, and you have the equation of plane AX plus BY plus CZ equals to D. Then the distance between PT, you can use this formula, AP dot N cap. What is this? Okay, if you recall, if we have 2 dot product, then we will multiply the parallel component only. So if you have these vectors, and you have these vectors, okay, let's say this is N, okay. Okay, you dot product them, you actually dot product their parallel component. Okay, this is what happened, okay. So this is the parallel component. I call it APY lah, okay. I call it APY. This is the, okay, horizontal component. I call it APX. So when you use dot product, when you perform AP dot N, I say N first, okay, I don't want to say the cap first. If you perform AP dot N, is actually this multiplied by this. What happens to this? Okay, this one multiplied by this N equals to 0. In the definition of dot product, the perpendicular component multiplied together, you get 0. So when you multiply AP with N using dot product, is actually the component that is parallel to N is getting multiplied together. Okay. Okay, so is AP dot N is actually APY times N. So I write as APY times, okay, is you will find the magnitude, okay? Sorry. So actually is AP, okay, the magnitude of AP times with magnitude of N. Okay, so now if APY, okay, magnitude of APY. So if APY is the component of AP, right? Which is parallel to this. The APY is actually equal to PT, the length of PT, okay, for APY. So if you manage to found APY, you manage to found the shortest distance. But over here, we multiply by n, it's still multiplied by a number. We cannot get the shortest distance, right? Okay, so what happens here is you don't multiply by n, you multiply by its unit vector. When you multiply by its unit vector, the magnitude of the unit vector is actually 1. Okay, so since the magnitude of unit vector is 1, you get APY. Okay, where your APY is actually equals to the length of PT. Okay, that's why they use this one to solve it. Okay, but over there they put the modulus just in case if you use like opposite direction, maybe the normal vector is pointing down, then you might get a negative value. So that's why they use the modulus, okay, to ensure that you found the positive magnitude. Okay, so if you don't get it, you can still memorize this method, okay, and memorize the way they do it, okay. Try better. It is better that you can try to understand it yourself, okay. So this one is just if they give you AP, okay, another point on the plane. What happens if they didn't give you another point on the plane? Okay, they just give you the equation of plane and the point. So what we can do is something like this, okay? Method 2, method 4, and method 1. So if you have formula, you can straight to apply formula, but this one, if the marks is a bit high, better don't use formula, okay? You can try method 2 or method 4, okay? So let me discuss method 2. So for method 2, let's say we are given this point and this plane. So we must find a point T. Let's say we let a point T on the plane such that PT is perpendicular to the plane. Okay. Sorry. From equation, we form equation of line PT. Okay. We use by using this method, it form an equation of line. Okay, along PT. So equation of line PT should be position vector. We know the position of P. Okay. So P should be along this line. Okay. So position of P will be the position vector of this line PT plus lambda ABC. What is ABC? ABC is the direction vector of this line. Since we want this line to be normal to the plane, then this line should have a direction vector that is parallel to the normal vector. So we directly use the normal vector as its direction vector. Okay, so we can read out the normal vector from the equation of plane, right? We use the normal vector as the direction vector of this line. So after you add it up, you should get alpha plus lambda A, beta plus lambda B. Okay, it should be in numbers, okay? Just because here we don't have the numbers, I write it in the symbol form. So when the line intersect with the plane, when you say that the line intersect with the plane, we want to find the point T, okay? We want to find the point T. So when you say that the line intersect with the plane, actually is the R of the XYZ of the line equation equals to the XYZ of the pi equation. So the R over here is actually X, Y, and Z. Okay, so we read out the X component, which is alpha plus lambda A, Y component, which is beta plus lambda B, Z component, which is gamma plus lambda C, should be equal to the XYZ of the plane. So you can sub this into the equation of plane. Since A and alpha is constant value, you should be able to rearrange and solve for lambda. So when you get lambda, okay, you sub back to the equation of OT. Okay, where is the equation of OT? Okay, you sub back to the equation of R. So if you sub back to the equation of R, you get the coordinate of OT. Okay, why when I sub the lambda back to the equation of R, I get the coordinate of OT? Because the equation of R means that any points along this PT line, okay, like it doesn't only along this PT line, it should be longer than the PT line, but along that line, okay. So just now we solve for lambda. This lambda is for the position of a line of a point that along the line, okay, intersect with the plane. So the point that along the line intersect with the plane is actually the coordinate t lah, okay? So if you sub this condition lambda inside the equation and you add up, you should get the vector should be the coordinate, the position vector of OT lah, okay? So when you find OT, you find coordinate of T, you have coordinate of P, you can find PT. Okay, PT is this vector, okay? If you find PT, okay, you manage to find PT, then the distance is equals to magnitude of PT. Okay, you just find the magnitude of PT, you will get the answer, okay? So magnitude is actually square root x squared plus y squared but plus z squared. But over here, I try to write in terms of the equation, I noticed that PT should be equals to OT minus OP, okay? So OT minus OP, this is what I will get for OT. I subtract the lambda, I should get something like this. Minus OP is alpha, beta, gamma. I found that I get lambda ABC. So distance is, okay, distance is actually the modulus of this. This is lambda multiplied by the square root of a squared plus b squared plus c squared. That's why it equals to this, okay? So normally you just sub the actual value, okay? Then you sub the actual value, then don't have something like this. Okay, this is to find the shortest distance from a point to a plane, okay? You need to memorize the method, okay? Then how about the shortest distance from a point to a line? Okay, shortest distance from a point to a line, there are also two methods. The first method is given that a point and a line. The second method is, let's say we are given the point and the line and also another point on the line, okay? So if we have another point on the line, let's say A, and the point P, we have to find P to T, then you can find AP first. You use AP to find PT. Similar to just now how we do for the planar, okay? So, or even it directly give you, or let's say the previous part, you managed to find AP, you can use AP to help you to find PT. Okay, let us discuss this method too first, because it is possible to come out in the question, because normally the previous part will ask you to find something first, then it has a high chance that you might find some vector AP, which is not the shortest length, okay? The shortest vector is PT, which is normal to the line. So let's say we manage to find AP, okay? If you don't have AP, but you have another point A, you can just use some simple, okay, subtraction to find AP, okay? So let's say you have AP and you have the equation of the line. How should I find PT? Okay, the idea is like this, okay? You need to find, because you have the direction of the line, you have direction of vector of the line, which is B. So you need to find out the unit vector of B first. I use a method that is similar to just now how we find the shortest distance to the plane, okay? So if you have the vector AP, then you have one direction B, direction vector B, then you can use AP dot B dot B, okay? You dot the direction vector of B, you dot the unit vector of B. Why we dot the unit vector? Because if you dot the unit vector, what you get is something like this. Okay, when you dot it, you actually is this AP, sorry, I call it AP, okay, better I use parallel, okay, AP parallel, okay, this one is AP perpendicular, okay. So what you get is, this one is AP parallel, the magnitude of AP parallel multiplied by B cap. The magnitude of B cap is 1, okay. Then you'll get AP parallel, okay. So AP parallel is actually equal to AT, the length of AT, okay. So we want to find this AT first. Okay, why we don't want to directly find PT? Why we don't want to find PT? Because we don't have the vector that is along this PT, okay? We just has one vector that is along this line. So we find AT first. Okay? So we don't dot with the whole vector, you know. You dot with the direction vector, the unit vector. That's why you find the unit vector first. if you dot with the whole vectors, it will multiply by some other values which might make the length longer or shorter. We want to dot it with a magnitude of 1 so that it will directly get its parallel component to this vector. Okay, then this length will equals to 80. Okay, so how do we find 80? Okay, so we found 80. Okay, we found 80 by using dot product. Okay, AP dot B cap. Okay, then we also find the length of AP. Okay, the magnitude of AP. So this is a right angle triangle. When you find AP, you find AT. You can use Pythagoras theorem to find PT. Okay, so if you find AP, you find AT, you just use Pythagoras theorem to find PT. That is how this method works. Okay. So the most important thing over here is this. If you don't know how to use this, you might not be able to use this formula. And remember that the B that is being dot is a unit vector. Okay. Then here is another method. Okay. For this method, it doesn't require you to know another point on the line. So let's say if you don't know another point on the line, this is what you can do. So given that the point P and the equation of line, it just gives you one point P. Okay. So what you can do is, if PT is the shortest distance, then PT is perpendicular to L. So if PT is shorter distance, then PT must be normal to the line L, right? Okay. So what we can do is we think that PT lies on the plane that pass through normally, the line pass through normally. Okay. So we think that we can thought of it as there is a plane that PT lies on it, and the line just pass through normally pass through the plane. So the direction vector of the line should be the normal vector of PT. Okay, so the direction vector of the line, which is ADE, the direction vector of the line DEF, should be the normal vector of the plane. Okay, then the one of the point on the plane should be the point that are given. Okay, so we have one point on the plane which is P, right? So we can put this point as the position vector. Okay, sorry, this I wrote it wrongly. Okay, this one I wrote it wrongly. This one should be alpha, beta, gamma. Okay, I should correct this. This one should be alpha, beta, gamma. Okay, luckily I saw this. Okay, this one should be alpha, beta, gamma. Okay, should not be ABC. Okay, not ABC. Should be alpha, beta, gamma. Because this ABC is some point on the line which we don't know. What we know, the point on the plane is this alpha, beta, gamma. Okay, so after we using dot product, we found equation of this plane. So we have equation of this plane, equation of this line. We can find the intersection. The intersection will be point P. Okay. So how we find the intersection is we sub the equation of line inside the equation of the plane. So when we sub equation of line, we sub the x, y, z of the line inside the equation of the plane, we can solve for lambda. Okay. So after you solve for lambda, what you get is actually the coordinate of OT. So the coordinate of OT, when you have coordinate of OT, then you can just use the coordinate of OP and you found the vector PT. Okay? So when you found that the vector PT, the distance is just the magnitude of PT. Okay, just the magnitude of PT. Okay. So this is another method. Okay. Okay. Then there's another things that they might ask you is to find the shorter distance between two lines. What happens when you have two lines which are not parallel? Then they ask you to find the shortest distance. Okay, this one is a little bit more tricky. We also have two methods. Okay, among these two methods, I will prefer method 2 because I think it's easier. Okay, so I will not discuss this method 1. if you want, you can look it by yourself. I discuss this method too. So this what happens is, for this method 2, is given that one line L1. Okay, you have two equations of the line. One is this, one is this. Okay, so the vector connecting any 2 points between L1 and L2 is R1 minus R2. So if you have R1 means any point on the line 1. You have R2, it means any point on the length R2. So if you use R1 minus R2, okay, so let's say this is the origin, this is R1 vector, this is R2 vector. If you use R1 minus R2, actually what you get is this. Okay, this is R1 minus R2. Okay, R1 minus R2 means R2 become the opposite. You come from here, walk to here, then plus R1. Okay, this is R1 minus R2. Okay, so R1 minus R2 is the vector that connecting R2 to R1, okay, between any 2 points, okay, because you doesn't know the actual lambda and mu. Okay, here we use lambda and mu. Because you don't know the actual lambda and mu, that's why over here, okay, you not sure which point. So which R1 minus R2 that we want is the XY over here, such that when these 2 points connecting these two lines, the lines are perpendicular to both lines, okay? This should be the shortest distance, okay? Shortest vector that connecting the two lines. So how should we do that? We want to ensure that R1 minus R2 is normal to both lines. Okay, you can do this by, okay, R1 minus R2 is the shortest when it is perpendicular to both lines. So if you use R1 minus R2 to dot with the direction vector of line 1 should be equals to 0. We say that if they are normal, then we use the dot product to dot their direction vector, they should equals to 0. Then I use R1 minus R2 to dot with direction vector of line 2 should also be equals to 0. So when you perform the dot product, you have two equations and you have actually two unknown. One is lambda, one is mu. You should be able to solve for the lambda and mu from the two equations. Okay. So when you get the lambda and mu, this lambda and this mu should be the condition that the line R1 minus R2 is the shortest. So you sub the lambda and mu back to R1 minus R2, you should get the distance. Okay. You should get the R1 minus R2 is the shortest vector. Then you just find the distance as the magnitude of R1 minus R2. Okay. Of course, here is another method. This method you can look at yourself. I think this method is easier. Okay. So I prefer you use this method too. Okay. Okay. So another type of questions that they ask the most is the angle between lines and planes. So it can be angle between two lines, angle between a line and a plane, and angle between two planes. So I'm not going to discuss more on this because this is quite common. Okay, so for angle between two lines, we just use the direction vector of these two lines. Okay, we identify the direction vector of these two lines, then we use dot product to dot these two lines. So the direction vector is B. Let's say the first line is B1, the second line is B2. Okay, B1 dot B2 equals to B1 B2 cos theta. Okay, so if you have vector B1 B2, you can find all of these four terms. Then you can solve this using arc cos and find the theta as the smallest angle between the two lines. Okay, the angle between the two lines. Okay, so if you have a line and a plane, then it is more difficult. Okay, you need to identify the direction vector of the line. You need to find the normal vector of the plane. Then you use formula of dot product. Okay, but over here you should use b dot n equals to bn cos 90 degree minus theta. Then the theta only is the correct answer. Okay, here we have a formula that we make up. Okay, which is modulus b dot n equals to bn sine theta. If you find the direction vector, you find the normal vector, then you use b dot n equals to bn sine theta. Okay, notice that here is the dot product. Okay, b dot n equals to bn sine theta. Over here you need to modulus it. Why we need to modulus it? Because we want to find the positive acute angle. Okay, sorry. Over here, there is many things to discuss, okay? But after some derivation, we can get this formula, okay, from the equation above, okay? You can memorize this equation and use it to find the angle between a line and a plane easier. Okay, sorry. So what happens if you have two planes? Okay, if you have two planes, that is very easy. You just identify the normal vector of the two planes. Then you use n1 dot n2 equals to n1 n2 cos theta. The angle you solve should be the angle between the two planes. Okay, for this three, you can just memorize this formula. Then you will be able to solve it. Okay. Okay, so a little bit more, then we can go to discuss the partial a bit. Okay, so for intersection of the line and the plane, when you it's very common to find the intersection between two lines, a line and a plane, and two plane, right? Okay, so for two lines, I think it's very easy lah. Okay, so the better way is that you write it in the vector form. So in a form like this, if you write it in the form like this, then when the two lines are intersect, you just put R1 equals to R2, then you equate A1 plus lambda 1B1 equals to A2 plus lambda 2B2. You solve for lambda 1, okay? You use simultaneous equation to solve for lambda 1. Of course, there are two lambda 1 and lambda 2, right? You just need to solve for one of the lambda, then you sub back to equation 1. Okay? You sub back to equation 1, then the point that you get should be R1, the coordinate of R1. The coordinate of the intersection point. So what happens if they give you something like this? What happens if they give you in the form of Cartesian equation? If they give you something like this, it's very easy. You just rewrite the equation into the form of vector equation. After you write in the vector equation, you use the same method as above. You can solve for the intersection point. Okay, so for line and a plane, if you have a line and a plane, it's very easy. So let's say if it's in this form, you just sub the R of the line, okay, into the R of the plane. So you will get something like this. A plus lambda B, okay, this A plus lambda B, you should add it up already, okay, dot with n, okay, equals to m, and you can solve for the answer. If it is given in the Cartesian form, let's say ax plus by plus cz equals to m, then this xyz, you just expand the line equation into xyz form, into the parametric form, then you put the xyz inside this equation. You solve for lambda, then sub lambda back to the equation of line, you can get the point of intersection. Okay. Okay. Then what you need to be careful is when there are two planes intersect, the intersection of two planes is a line. And you can find the direction vector of the line by using cross product of the two normal vector. Because the intersection of the line must be normal to both. The line should be normal to both the normal vector of the plane. So if it has these rules, then the direction vector n1 cross n2 equals to b. Why it must normal to both normal vector of the plane? Because the intersection of the line, you need to know that the line is lying on both planes, right? If the line lying of the plane, it means that the line is normal to the normal vector. Now it is lying on both plane, it means it is normal to both normal vector. So if it is normal to both normal vector, then you just use the normal vector n1 cross n2, you will get the direction vector of the line. So the more difficult part is to find the position vector. Okay, so if you want to find the position vector, we need to use trial and error method. Okay? Let's say we let the position vector as x1, y1, z1. Then we randomly choose one point. Normally we choose x1 equals to 0. We choose x1 equals to 0. Okay, we sub into equation r1 and r2. We try to solve for y1 and z1. After you solve for y1 and z1, you get a coordinate. If you manage to solve the equation, you get one coordinate, then this should be fine. If you doesn't manage to solve it, then you need to try another number for the x1, okay, until you will manage to solve it, okay. So you solve one, you manage to get one coordinate that's lying on the both planes, then you use this coordinate, okay, as position vector, then you can write out the equation of the line. The equation of the line will be, okay, the intersection of the two planes. Okay, so here are some special things, okay. So if, okay, equation of plane, okay, equals to 0. Let's say if you have a plane that is that is at x equals to 0, okay, that lies on the x equals to 0. How should you write? Okay, I remember this is from one of the past year. Okay, you see 2023. Find the point of intersection between line and the plane y equals to 0. So the plane y equals to 0, what is the equation? What is plane y equals to 0? Okay, y equals to 0 means, okay, let us try to view it, okay. Okay, I want to use the 3D. Okay, y equals to 0, meaning that, okay, the whole things, the number that can occur only occur at when it is y equals to 0. So if it occurs at y equals to 0, it actually lies on both x and y. You can see, right, it's on the xy plane. So y equals to 0 is on the xy plane. So if today I say x equals to 0, x equals to 0 should lies on the yz plane. Okay, the blue one is the x equals to 0. So if I have z equals to 0, it should lies on the xy plane, okay? So let's say we look at the x equals to 0 first. Okay, if you have x equals to 0, then what is the equation of the normal? The normal line should parallel to the x-axis, right? So I can randomly write one normal vector for this equation, which is 1, 0, 0. Okay, it can be 2, 0, 0, 3, 0, 0, 4, 0, 0, depends on you, okay? But the simplest one is 1, 0, 0. 1, 0, 0 means it has one direction, okay, along the x, then no direction along y and z, okay? So the direction vector is 1, 0, 0. Okay, for x equals 0, the direction is 1, 0, 0. Then y is equals to 0 because we can choose any position as the position vector, right? So if you notice that this plane must cut through the point 0, 0, 0, okay? It must cut through the origin. So since it cuts through the origin, one of the point, okay, if we solve a dot n, the point that we can use is 0, 0, 0 dot 1, 0, 0. So we can get 0 plus 0 plus 0, which is 0, okay? So here we get 0. So r dot 1, 0, 0 equals to 0 is the equation of plane x equals to 0. By using the same method, similar method, you can get equation of plane of y equals to 0 and z equals to 0, okay? You must know this just in case it asks you, okay? So it came out, okay, during 2023. Plane y equals to 0. Okay, so this is what from the intensive notes. Okay, so now we are going to proceed to the past year question. Okay. Okay, so for the past year question, sorry, I will discuss because of time limit, I will discuss the section A first. Okay, I will discuss section A. Then for section B, how about section B? Okay, because section A is the question that you must do, okay, you cannot choose. Then section B, you still have chance to choose, like at least like if you don't know how to do the vector one, you can like choose the other question. Okay, so But of course, if you can manage to master all questions of section B in vectors, then you have higher chance to encounter question that you can do. Okay, so it's better that you can master the question of section B, okay, of vectors. Okay, so now we are going to discuss the section A first. Okay, sorry, I think I need to go to the toilet for a while. I need about 2 minutes. Okay, so you can try to look at the question first. Okay, try to identify which part of the question that I have taught you just now is related to what I have taught you just now. Okay, then identify which part you have the idea to do. Okay. Okay, so let us continue. Uh, okay, so sorry. Okay, for chapter 6, section A, okay, let us see the first question first. Show that the point A lies on both plane, this one and this one. Hence, find the vector equation of the line of intersection of both planes. Okay, so how do I show that the point lies on both planes? If you want to show that the line lies on the plane, when you sub the value inside, it should if this point lies on this plane, you sub the value x, y, z into this plane, the left-hand side should equals to the right-hand side. So if you sub 2, 0, 0 inside this equation, you will get 4 on the left-hand side, which is equals to 4. Okay, if this is true, then it lies on this plane. Then the right-hand side, you do the same thing. You sub 2, 0, 0. If you get 2, then it lies on this plane. So over here, it lies on the plane. Okay, you can directly straight you see from your eyes, okay, you can know that, okay, when you sub these two value, you get, okay, something like this. Okay, your left hand side equals to this, equals to 4, which equals to right hand side. Okay, sorry. For another plane, when you sub left hand side, okay, equals to 2 minus 3 times 0 minus 2 times 0 equals to 2 equals to right hand side. Okay, so since left hand side equals to right hand side, okay, so okay, A lies on the plane. Okay, you do the same thing for here. Since left hand side equals to right hand side, so A lies on the plane. So since it lies on this plane and lies on this plane, so it lies on both planes. Okay. So find the vector equation of the line intersection both planes. So how to find the vector equation of the line of intersection of both planes? Okay, if you need to find the line of intersection of both planes, you need to find the direction vector first. So just now I said that the direction vector should be the normal vector n1 cross n2, right? Okay, this one will be the direction vector. Okay, so this question is very good because it gives you the position vector already. You don't need to use the trial and error method. You get the position vector. Later you can directly write the equation as this A as the direction vector plus lambda of the B you found. Okay, then you will get the line of intersection of both planes. Okay, so let's say we see the next question. Three vectors A, B, C are such that A, B are perpendicular and the scalar product of A and C is 78. Determine the values of P and Q. Okay, so A and B are perpendicular. What does it mean? It means that if you use A dot B, you get 0. Okay, so you can use this property to found A dot B equals to 0 from one equation. Because you have two unknowns, right? P and Q. Okay, now you have another equation. A dot C equals to 78. So from here, you get one equation. Here, you get the second equation. When you do simultaneous, you should be able to solve P and Q, okay? So you can be able to solve for question A. Okay, so now it wants you to find the angle between A and C. How do you find angle between A and C? You have one vector, you have second vector. You want to find angle between these two vectors. Just use A dot C equals to AC cos theta. You just solve this, you can find angle between A and C. Okay, so question for this here is actually quite easy, okay? Quite easy, and it costs 7 marks. The question before is actually more difficult if you don't know how to do. 5 marks only, but this one 7 marks. So actually, if you already learn most of the methods in the vectors, actually you can solve most of the question in matrix. Sorry, not matrix, it's vector. Okay, vector, the question it cannot came out too difficult. Okay, it has the every question have a similar pattern. Okay, if you already know the method, then you can solve more of the questions. Okay, so during 2015, okay, it says that the line, this one is perpendicular to the plane, this plane. Okay, so this time it gives you the plane equation using the parametric equation, which I say that it seldom came out, okay, but never mind. Where P and Q are constant, lambda st element real number. Okay, so determine the value of P and Q. How do you do this? Okay, so you see, this one, the line is perpendicular to the plane. So the plane should be something like this. Okay, then the line perpendicular to it. Okay, okay. So you remember that the S and T over here, I say that it is actually two direction vector that lies on the plane. So S and T should be something. Okay, let's say, sorry, not S and T. Let's say I call this B. I call this C. Okay, so B should lies on this plane and C is also lying on this plane. Okay, so if this line is normal to the plane, then it should be normal to both of these lines. So you should use the direction vector of this line, okay, this one. Okay, you use this one to dot product to B. Let's say I call this A. If you use A to dot product with B, you get 0. If you use A to dot product with C, you should also get 0. From these two equations, you should be able to solve for P and Q. Because you have two unknowns, you need two equations to solve for it. Okay, so if you solve this, you get 5 marks. Okay, for the first part. Okay, so for B, find the position vector of the point of intersection of the line and the plane. So how to find the intersection between the line and the plane? I have taught you just now, right? You sub the equation of line into the plane. So for this equation, the target of U should be you want to find the okay, over here it give you the parametric form, right? Parametric form we seldom see. Okay, so maybe what you can do is, because you found the direction vector of this line is actually the normal vector, is actually normal to this plane, right? And you know one of the position of this plane, which is phi 0, 1, right? This one is one of the point on this plane, position of one plane. So actually you can form the vector equation of the plane first using r dot n, where your n should be this a, okay, 3p1. Okay, you should be, if you solve under here, you should already find your p value already, okay, equals to a dot n. Your a should be 501 dot this one 3p1. Okay, over here you can form one equation of the plane, the vector form. Okay, a vector form is what we are more familiar with. Okay, this one we are not familiar with. So we form one equation of the plane, then we have equation of the line. We just use the method we discussed just now. You sub this equation inside, you solve for lambda, then you sub the lambda back to r. You can find the position vector of the point of intersection. Okay. Okay. Next we see the question 6. The lines L1 and L2 have equations r equals to this one and r equals to this one, where S and T are parameters. Show that line L1 and L2 intersects. Okay, how to show that they intersect? If you want to show that the lines intersect, you try to find the point of intersection. You equate this equation and this equation. You equate both equations. So when you equate both equations, what you will get is, okay, 1 plus S, 2 plus S minus S equals to 1 plus 2t, 3 plus 3t, 1 minus t. Okay, so now you can form three equations, right? From here, this is one equation, this is second equation, this is third equation. Okay, so you use first two equations, you do simultaneous, and you can solve for the value of S and T. So if these two lines actually intersect, the value of S and T that you solve, you sub into the third equation, then you, if you can prove that the third equation, left hand side equals to right hand side, then the two lines is intersect. Okay, this is what we do now. Okay, so you can try to sub the first equation, second equation. After you sub, you found S and T. Use third equation to prove that the third equation, left hand side equals to right hand side. Then this means that line L1 and L2 is intersect. Okay, so B, let's say after you found this, find the Cartesian equation of the plane which contains lines L1, L2. Okay, what if we are not able to do part A? Let's say we don't have the idea to do part A. Okay, if you don't have the idea to do part A, here we still manage to do part B, because without the answer in part A, it seems like it doesn't affect the answer in part B, right? Okay, so find the Cartesian equation of a plane which contains line L1, L2. Okay, actually it affected that, okay? Because in part A, when you try to solve the point of intersection, okay, when you try to solve the point of intersection, you when you try to show that they intersect, actually you found a point of intersection now, okay? But actually it doesn't matter, because the position vector, because since the plane needs to contain L1 and L2, so any position vector over here you can use as the position vector when you want to find the equation of the plane. Okay, you can use this also can. So we have the position vector. How about the normal vector? Okay, the normal vector, since the both of the line okay lies on the plane, so you use the direction vector of the line, you cross them together. Okay, so let's say this is B1, this is B2. Okay, the normal vector is equals to B1 cross B2. So you get the normal vector. Then the direction vector A, you either use this one or you use this one. Since these two lines all lies on the plane, so you either use the any point on the line, okay, you also can use as the position vector. So this one is position vector of the line one. So it must also can be used as the position vector of the plane. Okay. So if you have A, you have N, you can use R dot N equals to A dot N. So R dot N equals to A dot N. The R, you just expand it as X, Y, Z, then you dot it out, you will get the Cartesian equation. Okay, so for 2017, the points A, B, and C are vertices of a triangle ABC. The position vector of points A, B, C relative to the origin are this one, and this one respectively. Okay, so it gives you 3 points. Find a vector which is perpendicular to the vectors AB and AC. Okay, so it asks you to find the vectors that perpendicular to AB and AC, right? You find AB first, then you find AC. Okay, you find AB, find AC. AB and AC, you can find it using, okay, difference of two of the vectors. Okay, so AB should be equals to AO plus OB, right? You from A move to O first, then from O move to B. So AO, we don't have AO, we have negative OA plus OB. Okay, by using this, you can find AB. AC, you can do the same thing. You from A move to O first, then from O move back to C. So we don't have AO, but we have OA. So we have negative OA plus OC. You can find AC. If you have AB and AC, then you use cross product. Okay, you can find a vector that is perpendicular to both. So the normal vector should be AB cross AC. Then you can find A. Okay, then calculate the triangle of ABC. If you notice, I have the formula. Okay, for triangle, this one you just directly apply the formula. It should be equals to half of AB cross AC. Okay, so just now you found the normal vector, right? Actually, it's just the normal vector divided by 2 lah, okay? Magnitude of normal vector divided by 2. Okay, 2018. Determine whether line, this one, lies on the plane, this one or not. Okay, 4 marks only. So how to determine whether a line lies on the plane? Okay, if you want to determine that a line lies on the plane, sorry. Okay, if you want to show that a line lies on the plane, you need to show that, okay, every chord, when you sub the x, y, z of the line into the plane, the left hand side equals to right hand side. Okay, so this one is a bit trickier. So from here, actually, this one you need to divide by 1 by yourself, okay? So the equation of the line should be r equals to 1, 2, 3 plus lambda 1, 3, 1. Okay, this one if you add it up, you should get 1 plus lambda, 2 plus 3 lambda, 3 plus lambda. Okay, so this one is your r. Okay, your r, okay, is x, y, z. Okay, so this one is x, this one is y, this one is z. You sub this x, y, z into the equation, the plane equation. You say that left hand side equals to 2 times 1 plus lambda. Okay, minus y is 2 plus 3 lambda plus z is 3 plus lambda. Okay, if you manage to solve that, this one equals to 3, then the line is lies on the plane. Okay, let us solve it. Okay, it's quite easy only. 2 plus 2 lambda minus 2 minus 3 lambda plus 3 plus lambda. 2 minus 2 plus 3, okay, you get 3, which is equals to the right hand side. So since left hand side equals to right hand side, therefore the lines lies on the plane. Okay, this one is quite straightforward. So it's only 4 marks. Okay, how about 2019? you have 3 points. Okay, it is 3 vertices of a triangle A, similar to what we get just now. Okay, so find PQ cross PR. Okay, this is quite straightforward. It already asked you to find PQ cross PR. Hence, find the area of triangle PQR. If you have 3 points, let's say PQR, okay, you want to find area of triangle PQR, you find PQ cross PR, right? You just use any two vectors cross together, okay? The area of triangle is equals to half of modulus of PQ cross QR. PQ cross PR, sorry. Okay, so if you manage to find PQ cross PR, then you find the magnitude of it and divide by 2, you can actually get the area of triangle. Okay, given that PQ prime equals to 2PQ and PR prime equals to PR, determine the ratio of triangle PQR to PQ prime R prime. Okay. So this one is the need to find the difference area of these two. Okay. So PQ prime equals to 2PQ. Okay. So how to do this? Actually, it's 2 marks only. It's quite straightforward because area of PQ prime R prime should equals to half modulus PQ prime cross PR prime. So PQ prime cross PR prime should equals to, since PQ prime is 2PQ, okay, cross 2PR, PR prime is 2PR, okay, you can factor this R to outside, you get 4 divided by 2, you get 2 modulus PQ cross PR. Okay, so this one is area of PQ prime R prime, okay? So area of PQR is this one. So you want to find the ratio should be equals to area of PQR, which is half of modulus PQ cross PR divided by area of this 2 modulus of PQ times PR. Okay, you should get this one can cancel out. Half divided by 2 is a quarter lah. Okay, this one is a little bit special. Okay, a little bit special. Okay, let us see the next question. So 2020, a line L passes through the points P and Q and meets the plane at point R. Find the parametric equation of L. Okay, so it wants you to find the parametric equation of L. How do you do first? You find the vector equation first. Okay, so it given that the point L passes through 2 points. So you use one of the points as position vector. Okay, let's say position vector A, you can use OP. Okay, or OQ also can. Okay, you do what you like. Okay, so how about direction vector? Direction vector should be, you have 2 points, you can use PQ. Okay, PQ as a direction vector. So PQ, you can find PQ by using PO plus OQ. So we don't have PO, but we have negative OP plus OQ. Okay. By using this, you can find the direction vector and position vector. Then you can first write out the vector equation first. So the vector equation is R equals to A plus lambda B. So since R equals to A plus lambda B, I say that your R is actually equals to X, Y, Z. Then A is something, okay, let's say like XA, YA, ZA plus lambda, okay, XB, YB, ZB. Here you should find some value, it should be some values. So your parametric equations should be X equals to XA plus lambda XB y equals to ya plus lambda yb, and z equals to za plus lambda zb. Okay, this should be the three parametric equation of the lines. Okay, now it says that the line passed through the lines meet the plane at point R. So it actually is want to find the intersection of the line and the plane. So you just sub the parametric equation, the three parametric equation into the equation of the plane, the x, y, z. Then you solve for lambda. Okay, you solve for lambda. After you solve for lambda, you put this lambda back into the parametric equation of the line. So you got the lambda, right? You can solve for x value, y value, z value. The x, y, z value is the coordinate value of R. Okay, because the R over here, the x, y, z over here actually is coordinate of some point along the lines. Then just now you found the lambda, right? The lambda fulfill the condition that the line intersect the plane. So that's why when you sub the lambda inside this x, y, z, you found a point on the line that is fulfilling, okay, the intersecting plane condition. Okay, so when you sub the lambda back into the x, y, z, you that the x, y, z is actually the coordinate of R. Okay. So the next question is 2021. The position vectors of points P and Q relative to the origin are this one and this one respectively. Thus, the point R divides the line PQ in a ratio to ratio 1. Show that PQ and OR are perpendicular. Okay. So it has 2 points P and Q. Let us draw it up. Okay, I randomly draw two lines out. Okay, so this is P, this is Q. Okay, so there is one R that divides PQ into a ratio of 2 ratio 1. So PQ 2 ratio 1, let's say like this. Is by R. Wait, sorry, I need to charge my laptop first. Okay. So show that PQ and OR are perpendicular. Okay. What you can do is you need to find the OR first. How to find OR? You can actually use the ratio theorem, right? Okay. You can use ratio theorem. Okay. You can use ratio theorem because you have OA, you have OB, you have the ratio. You can use this ratio theorem to find OP. Okay, so in that question, it should be OR. Okay, so you can use this formula to find OR first. Okay, so let's say you manage to find OR. Okay, let's say you manage to find OR. So when you manage to find OR, show that PQ and OR are perpendicular. Actually, it's very easy because you have P, you have Q. Definitely, you can find PQ, right? Okay, so PQ is actually equals to PO plus OQ. So PO is negative OP plus OQ. You manage to find PQ. Then you want to show that they are perpendicular. You just use PQ dot OR. If you found that it is equal to 0, then it means that it is perpendicular. Okay, so we use this property of dot product to show that they are 90 degrees. So PQ is quite straightforward. OR is also quite straightforward if you know ratio theorem. Okay, so you need to memorize this formula. Okay, of course you don't need to memorize you can if you can use the vector. Okay, use the vector addition to find OR by yourself is also doable. Okay, so if let's say you don't know the ratio theorem, you can find PQ first. If you find PQ, okay, you know that PR is actually 2 over 3 PQ. Okay, so PR is like this. Okay, PR is 2 over 3 PQ. So you have OP, right? OR is actually OP plus PR. Okay, so if you don't know ratio theorem, it is still doable. Okay, OR will be equals to OP plus PR. Okay, so if you manage to find PQ first, then OP plus PR should be 2 over 3 PQ. Okay, you add it up, you can still find your OR. Okay, so next question is question 6. Given that ABCD is a parallelogram where position vectors of ABC are these three, and find the position vectors of D and determine angle of ADB. Okay, so if ABCD is parallelogram, it gives you three coordinates. Want you to find the position vector of D. How should you do this? Okay, if you want to do this, you need to know that for a parallelogram, okay, over here, okay, for parallelogram, if it is parallelogram, ABCD is a parallelogram, then vector AB equals to vector DC. Okay, so vector AB equals to vector DC. This is the, okay, for parallelogram. So parallelogram is something like this, A, B, C, D. So vector AB, since both of them are parallel, vector AB should equals to vector DC. So for this question, A, B, C, D, if you want to find the position vector of D, let's say you first let the position vector of D as A, B, C, okay? So you know that AB should equals to DC. AB is actually okay AO plus OB. Okay, DC is actually DO plus OC. Okay, so AO is negative OA plus OB equals to negative OD plus OC. So OD is equals to OD, you move to the left side, you move these two into the right side, you should get OA minus OB plus OC equals to OD. Okay, since you have OA, OB, and OC, you can find OD. Okay. Okay, then it asks you to determine the angle of ADB. How to determine angle of ADB? So this is A, B, C, D. So ADB, ADB means this angle, right? Okay. If you want to find this angle, you first need a vector dA and vector dB. if you have vector dA and vector dB, then you use dA dot dB equals to dA dB cos theta. You can find your angle equals to what? Okay, so you need to find angle and you need to find vector dA and dB first. After you manage to find dA and dB, you can use dA dot dB equals to dA dB cos theta and find angle theta. Okay, I see that it is about to reach 12 p.m. but I think we discussed until this question 2024, then only we end okay. Still a little bit more. Okay, so the part B, calculate the area of parallelogram ABCD. How to calculate the area of parallelogram? If you want to calculate the area of parallelogram, you need to use two vectors that are okay. There are two lines that are touching each other. Okay, you cannot use opposite. You cannot use something like this. Okay, or you cannot use something like this. Okay, you need to use two lines that are touching each other, either this or this, this or this. Okay, either one of them, they need to touch each other. So you get two vectors that touch each other. Okay, let's say AB and AD. So if you have AB and AD, the area of parallelogram is just sorry, modulus AB cross AD. Okay. We just use the formula of parallelogram. You can find it over here. Okay. Find area of parallelogram. We just use this formula. Okay. So for 2023, position vectors of point PQR relative to the origin O are these three. The plane has a vector equation this. Okay. Show that Q lies on the plane. How to show that the point lies on the plane? Okay, I say that you just need to substitute the point, okay, PQR, okay, just sub the point Q into the equation. You show that left hand side equals to right hand side. If left hand side equals to right hand side, then it lies on the plane. So for this equation, the R should be XYZ, okay? You can sub XYZ inside. Okay. Given the line L, which pass through the points P and R. So if you have one line L pass through P and R, find the vector equation of the line. So the line, you have 2 points lies along the line. With this, you can find the vector equation, right? You use either one of the point as the position vector. Let's say I use P as the position vector. Then you can have the direction vector B as PR. Okay. So PR we can find by using PO plus PR plus OR, which is equals to negative OP plus OR. Okay. By using this, you can find PR. So when you have PR, you have B, you have OP, you have A, you have A and B, you can write out the vector equation of the line. Okay, so the second question, determine the angle between line and the plane. How to determine angle between line and the plane? Just now I say you can memorize this equation. If you don't memorize, it will be very difficult for you to understand, quite difficult, okay? So normally we use this formula, B dot N, modulus B dot N equals to Bn sine theta. So over here, B dot N, B means the direction vector of the line, okay? N is the normal vector of this equation. So we use modulus B dot N equals to Bn. The Bn over here is only the magnitude, okay? Sine, remember this is sine theta, okay? So after you rearrange, you should be able to solve the angle theta as the acute angle, okay? The acute angle between the line and the plane. Okay, for question 3, find the point of intersection between the line and the plane y equals to 0. Okay, this is the difficult part because it wants you to relate about another new plane. Okay, it's not the plane above, it's another plane y equals to 0. So, okay, during that year, they does not manage to figure out what this y equals to 0 is. Okay, so now I have already given you, okay, just in case, okay, you couldn't get it, you should memorize this 3 plane. Just in case it came out, you know how to do it, okay? So for y equals to 0 should be r dot 0, 1, 0 equals to 0. So if you have the equation and you have the line, so you just do like the normal way we do it. You just sub the equation of the line into the plane, then you can solve for the xy for the lambda value, okay? After you solve for the lambda value, then you can sub back to the equation of the line and get the point of intersection. Okay. Last question. Given points A, B, C such that unit vector, this one is parallel to AB. And this one is parallel to BC. Okay, where lambda and mu are constant, if A, B, C are 90 degrees, find all possible value of lambda and mu. Okay, this one is quite different, but actually the same. Okay, so it wants you to find the value of lambda and mu. Okay, how should we do it? Okay, we use the info that it gives us. Okay, so it says that this one is parallel to AB, this one is parallel to BC. So if this one parallel to AB and this parallel to BC, if ABC is 90 degrees, that means these two vectors, their dot product should be 0, okay? So this one, if you use this one, okay, this one you dot with for 1 mu, okay, you should get 0. Okay. So you try to solve the dot product. 4/3 plus lambda over 3 plus 2 mu/3 equals to 0. Okay, you can get one equation now. Okay. So from one equation, you couldn't solve for the lambda and mu. You need a second equation. What else information we have? Okay, we have this unit vector, this one. Okay, so this is actually a unit vector. If it is a unit vector, the magnitude should be 1. So if it is a unit vector, then the magnitude of this, which is 1/3, 1 square plus lambda square plus 2 square should equals to 1. Okay, so you can solve for this. You have another equation. You have two equations. If you have two unknown, you can solve for lambda and mu. So from here, you should get two value of lambda. Okay? From here, you should get one. You should get another two value of mu. Okay. Okay. So you find that why so easy are the vector questions? Like from what I discussed. Okay, because this is for section A. Section A is the easy part. Section A, it doesn't ask you about. It doesn't require you to think much into details. It just like apply what you learn. So that's why our target is to target section A, do as much as we can. Then for section B, depends on luck. Okay? Let's say if it came out something that we really we really familiar, then it's good to us. If not, then don't struggle too much. Okay, you can focus to do section A more so that you get higher marks. So let's say, okay, section B. Section B will be quite difficult because it has many parts and it involves, okay, not the normal question anymore, okay, but sometimes it's still ask about the normal things, okay. So you need to see. It's better that you know vectors because the topic is quite small. Then it also came out quite frequent in the section B. So if it came out, you not only benefit your part A, section A, it also benefits your section B. Okay, so I suggest okay, it's better that you focus more on the vector question. So just now I discussed all these vector question for section A, right? At least you know how to do all of this, okay? Then you can try to, if you already managed to do all the section A question, you can proceed to do the section B question, see that if you have idea to do all of it. Of course, the trick is like this. We the most of the time we couldn't manage to do all of the questions, but we can target the part that we can do, like something like show that this is perpendicular to both of these. We can do, right? We just use dot product. We can show that they are perpendicular. Then after that, if we don't know how to do, it's okay. Okay, it's okay. Just that we try our best, okay, to do what we can do. Okay, show that this angle is equals to this. We can do. Find the Cartesian equation of the plane. We can do. Determine the coordinate of point P. Or maybe we can do. Calculate the acute angle between line and the plane. We can do. Try to search as much as possible part that you can do. Okay, and try your best. Okay, it's okay to not be able to solve all the questions. Just that you need to solve all the questions that you don't know how to do. So I think today is until here only. Okay. Thank you very much. You're welcome.